Welcome. Today's webinar is on security in the IoT ecosystem, the role of PKI in IoT. And my name is Randy Vanderhoof, and I'm the Executive Director of the Secure Technology Alliance, formerly known as the Smart Card Alliance. Today's webinar is being recorded and will be available for playback along with the presentation deck after the webinar has been concluded. Also, there'll be time at the end for questions, so I encourage listeners to submit their questions using the user dashboard on your screen. And I'll return at the end of the presentation to lead the Q&A and encourage you to submit questions while Josh is presenting so that we have time to organize them in advance and so we can get to as many of those questions as we have time for. We can go to the next slide, please. So for those of you who are new to the Secure Technology Alliance, let me give you a brief overview. The mission of the Alliance as a not-for-profit multi-industry association is to work on stimulating the understanding, adoption, and widespread application of secure solutions. And we do this in a collaborative, member-driven environment. We focus on education and information about how smart cards, embedded chip technology, and related hardware and software can be adopted across all of the markets in the United States. That's a very broad mission, and on the right side of the screen, you'll see the principal markets that we focus these activities on, including access control, authentication, healthcare, identity and management, Internet of Things, which is the subject of today's discussion, mobile payments and transportation. And our member organizations benefit from participating in these groups by getting access to training and certifications, participating in industry councils, working with us on education and receiving education about new topics, how we support for industry outreach and networking activities, and keeping our members up to date with technology trends. So as a member-driven organization, we are primarily focused on bringing together stakeholders to collaborate on promoting secure solutions technologies and addressing the industry challenges in how those technologies are adopted. We do this through a number of different sources, white papers, certainly, webinars like today. We also do workshops and produce newsletters and position papers, and we have robust content on our website to communicate those thought leadership positions from our members. We create conferences and events that focus on specific markets and technologies. And often we are invited to be contributors at industry-leading conferences, particularly around the areas of IoT recently. Also, our members benefit by the networking opportunities they get to share with other industry leaders. And together we communicate those strong industry positions through our communications efforts and public relations activities that we conduct on behalf of the industry and the organization. We can turn to the next slide, please. So the IoT Security Council is one of many industry verticals that the Secure Technology Alliance focuses on. And these councils attract like-minded companies and individuals to identify and address priorities that will have an impact on accelerating adoption and growing the size of the market. You know, some of those priorities include accelerating market adoption for secure IoT architectures, providing a forum for intra-industry and cross-industry collaboration on secure IoT architectures, providing a business-focused organization to discuss best practices and the implementation of IoT architectures using embedded security and privacy, and providing a single organization where all industry stakeholders can network together, share their information and experiences, and discuss applications and security approaches. And a lot of our work is focusing around identity as well as the collaboration with other industry organizations to define and promote standards for secure IoT architectures. On the right there, you see a graphic of a web information portal that we've put out called the IoT Security Connection, where we produce content that includes original content from the Secure Technology Alliance, as well as articles and publications that we see from other industry resources that we feel are of particular value to the industry that focus around the issues of security. And some of the publications that have been produced already by the Alliance include white paper on blockchain and smart card technology, embedded hardware security for IoT applications, the implementation considerations for contactless enabled wearables, and IoT and payments that look at the current landscape. If you can go to the next slide, please. So this is the first of a series of two IoT ecosystem webinars that the Secure Technology is producing. Today's topic is going to explain the role of public key infrastructure, PKI, and how that can play in securing the IoT ecosystem. And then we have a second webinar in the series scheduled for next week on May 22nd. And this webinar is entitled Trusting Data at the Edge, and it will review the security requirements for trusting and managing data collected and or stored at the edge of the IoT network, and approaches for ensuring data integrity, privacy, authenticated access control. By registering for today's webinar, you've already registered for this second webinar, but we recommend manually updating your calendar with the link and dial-in information for the May 22nd webinar, because you won't receive another registration confirmation email from GoToWebinar. Also, there's going to be an online assessment quiz available for both webinars in the series. And if you participate in the two webinars and pass both of the assessments, you'll receive a Secure Technology Alliance certificate of participation for your accomplishments. So now if we go to the next slide, let me introduce you to today's presenter. So Josh Jobs is the Vice President of Certificate Solutions and General Manager of IoT at Entrust Datacard. He has more than 20 years of experience gauging the practical impact of changes in the technology ecosystem. And before joining the company, he directed investor management engagements as an equity analyst in the security and financial technology sectors at Roth Capital Partners and Piper Jaffray. He also held roles within the United States government, specializing in new technology investments and security research. Josh holds an MBA in electrical engineering and received his bachelor's degree in electrical engineering from the United States Air Force Academy. So now I'm going to turn things over to Josh. Josh?
All right, thanks, Randy. So for those of you, I guess I should say, thanks to everybody who's joined. For those of you who know Entrust Datacard history, have been in the PKI space since the first commercial solutions came to market in the late 90s. PKI is one of those areas that continues to evolve with each major change in technology or application of technology. So about 5 years ago, we decided, as IoT was becoming a bigger topic, as the sort of targets for where technology be applied became a little bit more front and center, we decided that this was going to be another one of those evolutions that PKI was pretty well aligned with the needs that, or to solve some of the challenges within the IoT space, but that it was going to need to evolve to solve some of those unique challenges. And I'm hoping to share some of that with you today. So we see the title of the presentation, the role of PKI in IoT. So if I just cut straight to the answer, the role of PKI in IoT is to establish and maintain a degree of trust in our environments as we roll out these hyper-connected and interactive ecosystems. And we'll get into the details, but we'll see that the problems PKI solves, and very importantly, the way that it solves them, align well to the unique requirements of IoT. And given the concepts and the technology has been tested for decades in some of the most sensitive environments, it's not a surprise that PKI has become sort of a foundational element in the emerging standards and best practices within the IoT space. But it's not just PKI as is. There are some special considerations for utilizing the approach within IoT, and we'll touch on those as well. Next slide. So when, depending on your perspective, when the, IoT is a fairly loaded term, right? It's a concept that applies across industries. Some people, gravitate toward things that they see every day. So things like wearables, connected toys, even sometimes, those type of things. But the largest IoT opportunities really apply to some of the most sensitive or critical environments. If we think about in medical care, transportation in a few specific areas, energy and utilities, industrial automation, very sensitive, safety, when you think about things like safety and resiliency and reliability, we're really starting to connect some of the most critical assets that are out there today. Next slide. And it's interesting when you think about IoT, or sometimes digital transformation is a term that gets used. It's a really loaded term, right? And I think over time, probably even the term IoT will sort of fade or just become sort of the next evolution of business in each of these ecosystems. But they do share some things in common. So leveraging kind of cheap mass connectivity, the ability to connect something, the scale that you get through the cloud concepts, the analytics, so the power to analyze data through things like artificial intelligence and machine learning, and the big investments and kind of rapid advancements happening in that area, and then mobility, being able to interact with the world wherever you are, whenever you want to. Next slide. And there's a whole bunch of different, surveys and studies that are out there in terms of the number of devices. What they all amount to is that we're going to connect everything, and there's going to be lots of connected things out there. But you can see that where they apply from a connectivity perspective, where is this stuff really going to show up? And once again, you start to highlight some really sensitive environments. Next slide. So as we bring these new concepts to bear in industries that have in some ways been largely disconnected, environments have largely been disconnected or connected in isolation over the years, there's studies out there that say trillions in savings and big opportunities, and it's going to be fantastic. But obviously there's a risk there as well. And I think for people that are joining the call, it's a good sign, trying to get in front of some of the issues. I think there will be some failures out here. We've seen some of that in different industries already. But it really comes down to really addressing the risk, making sure that as we do these big, great things, that we can trust the ecosystems that are going that are being connected. So the first polling question, we have a couple of these, but just kind of looking for the audience we have today, what's the status of your organization's plans for IoT deployment? And we'll wait a second here for everybody to click on the answer. All right, so we're pretty distributed here. It is interesting, and we'll highlight this one because it's a good jump off point to the next slide, that it doesn't look like we're, for the new projects that we have come in the next 12 months, that we're necessarily aligned or at least as comfortable with the security approach that's being taken as we'd like to be. It's not a surprise that we have some distribution here, given the kind of broad sweeping impact of IoT. So everybody in slightly different states of adoption. If we go back to the slide, there's a number of polls that are out there today, everything from, Bain, the big analyst firms do these type of surveys. So, you know, when it comes to challenges to IoT adoption, if you think about everything that has to go into making a project successful, cybersecurity is still the one that people are getting hung up with, and I think there's good reasons for that. In that there's some unique needs in there, and the risk generally in these environments is pretty high if we don't get things right. Next slide. There is starting to be more maturity. So part of the challenge with cybersecurity and IoT is just it's evolving. Standards, best practices are maturing. There's been, if we go back 3 years and look at things and we look at them today, there's been a lot of progress in that area. That getting down to the point now where there's some very practical advice that's coming from organizations like STA and IC and Cloud Security Alliance and some of those groups, making it a little bit easier for individuals that are responsible for the projects to come in and accelerate some of that work. The other area is that within, just like we've done with IT over time, the industry is starting to do a better job of sort of tracking through where the targets are, where the vulnerabilities, the bigger vulnerabilities are, and starting to lay that out in easier to consume method. Next slide. And there are some new security challenges. So if we think about our IT environments today, there are a lot of Windows, a lot of Apple and Android type devices, but that's still a pretty homogeneous environment, and it's been that way for a good decade. As we look out into the environments of IoT, we see a high disparity in the types and the capabilities of devices. We're doing that at scale, high volumes. The standards are maturing, but still relatively immature compared to what we see in the IT space. Privacy, I think, is front and center kind of across the industry right now, and you bring a lot of those questions with IoT as well. So some new challenge out here, reliability, safety, those are categories too that generally are more present in the world of IoT and operations than they've been in the world of IT. And so if we lay out, next slide, if we lay out how to think about this, this is if you're an IT architect working on a project, this sort of reflects that view. It's a kind of a high-level 3-tier architecture, which is pretty common in IoT deployments. But we can separate that out a little bit into OT and IT. And on the IT side, there are some new things, but generally the things that we've been doing from a cybersecurity perspective in the IT world still apply here, right? It still looks a lot like IT. On the OT front is where a lot of the things I just mentioned, a lot of the new challenges are as we get out to the edge, as we get out into the operating environments. That's where some of the new things, the new considerations start to be. One of the other differences is that a lot of our IT practices have really centered on the user. So there's been a lot built up over time on, how do you provide the right controls, the right education, and those type of things when there's a user present. And as we go into the world of OT, and we see it a little bit in sort of the DevOps context as well, but as we go into OT, it's more about things and services, and we have to do things a little bit differently as we move out into like large scale environments that have more of that style of endpoint involved. So we'll go to our second polling question. I spend a lot of time, and I'll let you go ahead and read through this, but I spend quite a bit of time, or at least over the last couple of years, on the organizational side of IoT and IoT security, just because we kind of bring in a new dynamic with the line of business owner, the product owners. We spend a lot more time with those groups versus in the traditional space. We're a lot more with the IT and security teams, and so it's interesting to see as those teams sort of come together, which parts of the organization are involved. and we can see on here, right, that a lot of individuals on the call today are from the line of business or the product team, and that's not a surprise. That's where a lot of the projects start. You're usually bringing in individuals from other parts of the organization, or what we've seen with some larger organizations is that they're directly embedding IT and security type skill sets within the product teams themselves. So I had mentioned at the beginning that PKI really plays in establishing trust in these environments, and taking a bit from the IC definition, having the confidence or assurance that a person, system, or thing will behave as you expect or as intended. So it kind of gets into that concept of, well, I need to know what it is, and I need to make sure that we can trust that interaction. So before we get into the PKI aspects here, just kind of level setting on what what's going on in this IoT environment. And one of the things that's a little bit unique for those of us that have worked in the IT space is that a lot of as you get into supply chain considerations and securing things at the earliest stages if possible, it's a lot more of an emphasis in the IoT space than it has been in IT. That's one of the, if I'm talking to a security professional that's just getting involved in an IoT project, that's one of the key things that we start talking about early on is that, does your product team, does your line of business have supply chain considerations? Is supply chain integrity important? In a lot of cases, it is. If you go into the industrial space, automotive space, things start right at the beginning. So from a life cycle perspective, you have, right down to the semiconductors, the chip providers, in through, where the modules are produced, then into actual manufacturing, being able to identify that device early on, be able to interact with it early on. But then eventually it goes into the operation space, which is, now I know what the device is. I know it's supposed to be here. I know it's an authentic device, but now I have to make it my device. It's going to be in my environment, and I have to be able to interact with it, knowing that it is one of my endpoints. And then that being managed, the device then has a life cycle. You may take it out of service. It might not behave correctly, and so you take it out of service. Maybe you put it back into operations. It starts transmitting data, you start interacting with it, you start provisioning services to your own organization, or maybe you have third parties that play in this. But keeping in mind that, security here is a life cycle. It starts very early in the process in IoT, and it goes all the way up to the point where it's decommissioned, which, if you go to the next slide, that's where we get into like the life cycle and how identity is used within that life cycle. So starting from manufacturing, provisioning the devices, deploying them, hopefully using automation, given you might not be in front of the device, you might have lots of them. So bringing as much, leveraging some of this to get as much automation and deployment as possible, and then monitoring, servicing, updating, and decommissioning. So in a minute we'll start talking about PKI, but some of these concepts start to be important as we get into the PKI conversation. So with that, I think we go to our next polling question. So looking here at your familiarity with public key infrastructure, you all were excited enough to join a webinar called the role of PKI in IoT. So that in itself is interesting. But let's see where we fall in terms of skill set. And this will really let me know whether the material I have next is going to be appropriate or not. So very curious on the result. All right, pretty good distribution. So for you experts on the call, it might just be a different way somebody tried to explain what PKI is, but we'll give it a shot here. So instead of jumping into the technical aspects of it, I'm going to explain PKI maybe a little bit differently. If it really starts with what problem we're trying to solve. Well, if the problem is really us trying to connect everything and trying to interact with everything. If we would stop doing that, we wouldn't have a problem and we wouldn't need to talk about PKI, but we do want to connect everything and we do want to interact with it. So wanting to make those trustworthy interactions. So what do we mean by that? The first thing is, how do I know who I'm talking to? Or if it's devices, how do they know what they're talking to? Are the parties allowed to communicate? So if it's your ecosystem, your infrastructure, do you want different parties communicating? How do I prevent others from listening in? Maybe I don't want others listening to the interaction. How do I make sure what was sent was received? So there we talk about, you talk about signing and message integrity and stuff like that, but really it's like the telephone game, right? So when you're a kid and there's you line up, 10 different students and the first student is given something to say and they whisper in each other's ears. And what we find is that by the time it gets to the last person in the chain, what was initially said and what was heard by the last individual isn't always the same thing. So whether that's done maliciously or done by accident, we want to make sure that, this digital form of interaction has some integrity. And then how do I prove what was said later? So do I want to be able to go back and audit what was said? Do I need to prove that something happened? And those come into some really, foundational technical concepts, authentication, authorization, and we could debate that one on the PKI front, but encryption, integrity, and those are all things that are sort of provided by the concepts and the solutions behind PKI. And there are some important concepts to think about. What we're talking about here is digital. So key, it really kind of comes down to keys and crypto, making everything work. And, in a lot of cases, you need to protect them accordingly because they are the foundation. It starts with registration. I'm using the registration term. Sometimes people say provisioning, but making sure, remember this at the very beginning, all the trust really starts with being able to, confirm an identity and know what that party is. And so it kind of starts with registration. I need at the very beginning to know who or what something is. It's a system and it'll evolve. So there's a lifecycle consideration here, and validation is required, and that concept really impacts performance when and how validation around I have these keys or the certificate, and is it still valid? Can I trust it? That's the part that happens sort of in real time within these infrastructures. So PKI is really set up to help with the trustworthy, making sure that the interactions are trustworthy by largely answering these questions. Next slide. So here's more of a technical definition, I guess, of what PKI is. The most important thing to highlight on this slide really is that it's not just software, it's not just technology, it's rules, policies, and procedures that need to be in place to make sure that we're creating trustworthy systems. And this is kind of where I'll leave the what is PKI component of this. I highlighted that there's lots of different ways to get deeper into the technology. It gets to be pretty heavy in some of the concepts, but there's training out there. I think my first training on PKI was in 2001, and it was through Learning Tree, funny enough. But we provide training. The other providers that are out there, I think, all have some level of training. There's books. You can jump on Amazon and grab your Kindle and go ahead and read as much as you'd like. So we go to the next slide. What's important about PKI, and I kind of highlighted this at the opening, is that we're really here. We're leveraging, we're leveraging concepts that have been proven out over a long period of time in really critical environments. So in sort of the standard environments, the things I have listed down here, and you see again, we're touching on sort of the authentication, signing, and encryption use cases, but these are all things that have been done for long periods of time in real sensitive environments, and PKI has kind of stood the test of time here, and been able to kind of prove that you can do this stuff at scale. So not a surprise that we're looking at it for IoT. If we go to the next slide. And this is where you kind of see some of the stats that are up there. I think the most interesting one is on the right, and this comes out of a PKI study, but you can see how quickly PKI or IoT has moved up sort of the PKI drivers list over the last few years, and I think that's partially because the IoT deployments are accelerating, and partially because the security maturity models are also maturing. And when you get into the world of things and devices, and especially away from the user kind of having the primary role, there's only so many ways that you can do this stuff at scale, and IoT or PKI tends to be kind of the most tested method for a lot of this that's out there. Next slide. So we talked about some of the benefits, but there are some challenges. Like if you were to just kind of go grab kind of standard PKI tech, there's a lot you can do with it, but there are some challenges with it as well, given where we're at in the diversity of devices, the things I talked about earlier. So the lack of embedded functionality within the OT infrastructure, so that some of that's being built in, especially in greenfield environments, but that's a challenge. PKI skills, so we know that security in general has the security domain, there's a big shortage right now, and it's expected to get worse for the next couple of years. PKI is sort of a specialized skill set within that. You know, the tools that are out there today didn't necessarily take all this into consideration. When they were built, they're working in more unconstrained environments. And then how keys are handled and how all this stuff works within those environments can start to change a bit. And so we go into that in a little bit more detail on the next slide. I wrote down some of the considerations. So these are things that we've seen through the engagements over the last few years. I mentioned the supply chain consideration, supply chain integrity. Brownfield versus greenfield is a huge one. So, you know, for greenfield devices, there you're starting to see a lot more come out of the manufacturers in terms of both the capabilities of the device and also what protocols and those type of things that support. And a lot of those today are certificate enabled. But you still have, in many cases, brownfield devices. And so thinking through how you're going to handle the brownfield environments becomes really important. The types of architecture, I mentioned the 3-tier architecture, which we see most commonly, but there's also two tiers, so sometimes the device is interacting directly with the service. In the case of 3-tier, looking at, you know, what are if we're deploying, let's say, to a series of manufacturing plants, what is the connectivity, reliability of that connection? Does more have to happen at the edge? And in many cases, the answer is yes. And so you need to start breaking up some of the functionality and delivering it in a certain way, so that it can be easily adopted by the operations environments. Manufacturing, there's a manufacturing scenario that kind of plays that same way. You know, how much do we trust that environment? As a result of that, how does implementation need to occur? Skill sets, organizational structure, I talked about that one early. That's one that's important to identify as early in the process as possible. Device provisioning and scale. So how much automation is desired? How, you know, based on those environments, what can be automated? You have the life cycles. So how in some scenarios you have devices with very long lifetimes. In other cases, you have services that maybe exist as long as a car ride. So that impacts the style of deployment that you're looking to support with PKI. Deployment preferences, so on-premise, cloud, hybrid. I would say most commonly for us today, it's the hybrid implementation, and there's some really interesting things going on in terms of everything from the level of assurance and where you want to have keys and offline routes and things like that, all the way into the needs of sort of that edge environment to be very, highly responsive. And so there's some very interesting things going on from an architectural perspective when it comes to PKI and IoT compliance requirements. So the one example I'll give there is, if you're in medical devices, it's interesting when we have that conversation. Traditional sort of security professionals from the IT space initially gravitates, or okay, we're going to deal with HIPAA and high tech. But in the medical space for IoT, it's primarily FDA, and FDA has safety requirements, and that's not something that IT-based companies have been used to dealing with all that often, and it's sort of mandatory to play in that world. Protocol requirements, so a lot of industrial protocols and different protocols are involved in at the edge within these environments, and then key generation and storage and how all that stuff takes place based on what's available in the architecture. So some of the considerations, some of the things that we run into early in the conversation with our engagements. Next slide. So why are we protecting our investments here? Once again, we're shifting from, more of a data protection philosophy, which there's an element of that, but really safety within these environments, corporate image and reputation, business continuity becomes huge if you have a manufacturing site that's compromised. Those are hard dollars. If you're running mining operations, it's kind of the same thing. So a lot more sensitivity to that than, say, having your email go down for 2 hours. You can kind of live with that. If your manufacturing plant shuts down for 2 hours, that's a much bigger problem. And it's not, so we covered a lot on the PKI front. It's not all about identity, and it's not all about what's provided with PKI. If you go to the next slide, it's a very good starting point, but it's not a silver bullet. What we found in IT over decades of continuing to try to secure those environments is that concepts like defense in depth, making sure that you're covered with things like monitoring, the role of concepts like least privilege still apply. So all those concepts that we've gone through and learned over the years on the IT side still apply here. I think maybe one of the differences is that given the nature of these environments, really getting the trustworthiness concepts, being able to identify what's in our environments, being able to make sure that the interactions are secure. Really, we go back to that as sort of the starting point for getting comfortable with these new systems that we're rolling out. Next slide. And I think that's it. So Randy, I'll turn it over to you for Q&A.
Yeah, thank you, Josh. There was a lot of great information shared there, so we really appreciate you taking the time to putting this deck together for us. We do have a few minutes remaining take some questions from the attendees today. Before we start the Q&A, if we could please advance to the next slide, I'd like to point out some additional information that'll be available to you. So first, as a reminder, we're offering the online assessment quiz after each of these 2 IoT webinar series. So if you participate in both webinars, either live or by listening to the recordings, you'll be able to take the assessment for each webinar, and if you pass both assessments, you will be eligible to receive a printed certificate of completion, which you can retain for your personal professional records. The assessment link for today's webinar is listed here on the slide. If you want to jot that down quickly, you can, but it will also be sent to you by email along with a link to the recording and the slide presentation from today, usually in a couple of days after we get this information uploaded to our website. Also, the next slide, please. Secondly, I want to point out that we have 2 websites where Secure Technology Alliance has made IoT security information available to the public. So I encourage you to visit the IoT Security Council Industry Information page that's available on the Secure Technology Alliance website. This includes a listing of the steering committee leaders and member organizations of the IoT Council and what that group's objectives and activities are. Also, the Secure Technology Alliance Knowledge Center has resources that are listed, including many of those listed here above. Plus, we have the IoTSecurityConnection.com information portal where you can continue to get updated information about this topic. So let's go to the next slide now and put up the speaker contact information as we begin the Q&A session. First question, Josh, is sorry, I missed my point here. Do we know why PKI is on the decline in cloud-based services, but on the upward trend in IoT? And is it the result of decreasing cloud services?
Yeah, I think on the cloud services, and then we're probably referring back to one of the slides I had in the deck. Cloud services from an absolute perspective is actually still one of the bigger drivers of PKI adoption. But I think in relation to IoT, what you're seeing is that IoT is becoming, it's starting to exceed. It's moving from, so cloud services is moving to number 2, and IoT is moving to number 1. So that's a little bit in relation to each other.
Okay. You talked about security in the PKI context. Can you speak to the value of utilizing hardware security versus using software or white box or other modes of securing the PKI content?
Yeah, so we, as part of PKI deployments, it's very typical, especially within the more sensitive applications, but we're seeing it more broadly now that hardware security is actually, for the larger ones, it's always been there, but it's becoming a little bit more pervasive on the back end side of it. So I'll talk about like where the kind of keys that are behind everything, where do those sit? That's where we see the adoption of hardware security modules. So you're basically putting your keys and your crypto processing in a vault. And so we see that growing in importance. It's something that we've always sort of had as an option for our customers. It's always been a best practice. Today, that is becoming more of the norm. The second one is is more on the device side. So, where for the devices themselves, where the key's stored. And I think that's where you're starting to see, when I mentioned the greenfield devices, that is, is sort of becoming more of a status quo, and the volumes are getting up there. So the costs of doing that are cheaper. That's, once again, that's a best practice where if you can get access to hardware-based security to protect those keys and to run that crypto, that's it's a best practice. It's the safest way to do it. It's the most secure way to do it. And as volumes have gone up and costs have come down, when we look at things like PLCs in the industrial space, even to some degree wearables, if there's payments involved, like you are seeing hardware-based security on the endpoint as well. It's not always an option, but we're starting to see it more and more in terms of either existing products that are coming to market or within different industries, how they're evolving with plans to incorporate hardware security in their designs.
I think this is somewhat of a follow-up to that question, related at least, Josh. What's the biggest challenge to provisioning devices with PKI, and how is that being done today?
So there's really two answers, I think, to that, or two aspects of it. The first one is for the newer devices that are coming out, or the devices that are already sort of certificate aware. So the provisioning there itself isn't necessarily overly difficult. We did take it a step further in terms of if the hardware exists but the software doesn't, if there aren't clients. We, on the other side of our business, are a manufacturer, and so we do know what what kinds of skill sets they have. So trying to make the elements of that really easy for a firmware engineer or design engineer on the manufacturing side to be able to incorporate into their designs. And so there's that sort of level. So there it's the first time for a lot of these industries that they've done it. So there's a learning process that has to happen. And you're trying to offset that with kind of easy access to tools that are brought out in such a way that it kind of fits how they do things. So try to reduce the education cycle. The brownfield's a little bit different. There, it's really around, whether or not can I update the device? And so we take two different approaches there. There are certain devices that you're just not going to be able to update, or they're too constrained. And so there is work being done on getting smaller footprints and things for those devices, but there's also, we take the approach to say you're just never going to get all the way to the device. So doing things like proxying at the edge. So you're driving security as far as you can down into the environment, and then you manage it with policy. The last piece I would point out is provisioning and really working in. There's a level of automation that's being brought into the IT space around certificates. But it's I think the importance because of scale has really driven a lot of the innovation coming out of IoT, and we actually see IT environments adopting IoT techniques for that reason. But there you're talking about, potentially setting up policy-based, rule-based type things that you might be doing different at the initial stage of provisioning. You might be using other information to sort of bootstrap the provisioning process. So that's another concept that we see that there's a lot of attention on that. We have customers that do that today, and it's an area that we've continued to build out because we think it's going to have a lot of value within these environments in terms of really trying to bring as much automation as possible into the provisioning step.
Okay. Next question is, what do you see as the role of the platform providers in IoT, such as Azure, PTC, and Amazon Web Services?
Right. So here we're talking about some of them being the big cloud providers, some of them like PTC developing a platform independently, but they all have IoT platforms today. And the use within our customer environments varies widely. It's one of the, it would be easier for us if there were like two IoT platforms that we had to focus on and just make sure all that worked together. But that's not the case. Whether a customer is using a single platform, we see a lot of variety there. We see a lot of big organizations using more than one platform. And then we still see a very large amount of organizations that are using their own data center and their own applications. And so we have to be a little bit nimble in terms of how we integrate into the IoT platform itself. The second one is and it varies by which platform it is, but if I take Azure as an example, and AWS is the same way, they provide sort of within their ecosystem, they provide a fair amount of security functionality, a fair amount of control. But what we see with the large organizations, really for two reasons, is a desire to kind of separate that aspect of the platform. And generally the platforms provide integration points because ultimately they care about the analytics, the applications, the data, providing value on that side. So they're very flexible in that area. But for the customer, it provides more flexibility by breaking those out. It provides a lot more flexibility in device selection, If you want to use more than one cloud platform, if you want to switch cloud platforms, having that independent from the provider provides a lot more opportunity for the organization. And then the second one is not really just, especially in this area, it's not really about like just the certificate or the certificate issuance function itself. It's how, if you went back to that list of things to look for, there's a lot more that goes into developing a PKI-based solution for an IoT environment than just cert issuance. And so if you want something that you can deploy and maintain that aligns well to an OT environment, you have to account for a lot of these other things. And so that's where a lot of the differences come between sort of what the platforms are providing and where we integrate. So generally we see the platforms as ecosystem partners. And I don't think, for a lot of reasons, I think that's the way that it'll look going forward for the foreseeable future.
Okay, we got time for another couple of questions here. So PKI has been used in environments that typically are able to support fairly costly and complicated implementations. But what's changing to lower the cost and simplify implementation to allow the use of PKI in the IoT systems to scale?
Yeah, I would, if we looked at, I mentioned some of the technical, evolution that PKI has a long history. And I do think from a complexity perspective, it kind of got stuck during one of the periods, like mid to late 2000s, maybe a little bit after that. But I think what's changing and largely there's opportunities for the companies that get this right. When you look at IoT and the scale that's required and automation that's required, if you look at the world of DevOps, which is kind of going to come next, it has a lot of the same, it's a different model that users care about different things, but there are some similarities in the areas of scale and automation. And so I think it really comes down to, leveraging advancements in technology that's happened over the years to simplify, things where they can be simplified. And I think in the areas of automation and provisioning and scaling, there's a lot of progress that's been made in that area. There's always an element when you get into policies and procedures that needs to be done correctly. We're finding, if I look at our IT examples, like the use of certificates and the need for certificates has been there. I think as IT as a whole kind of got away from best practices for a long time, and because of the critical nature of what's being provided by PKI, and because of I think it's the adoption has kind of increased without people recognizing it, and now they're going back and looking at their environments and having to clean a lot of things up. And so doing it right, we have one individual in the organization who says proper PKI, like doing things right doesn't necessarily have to be overly costly. And doing it right can actually, when it comes to things like automation, can have some benefits to it as well. But there is an element in there that it does fall into, taking the steps up front to make sure that what's being put in place really reflects the needs of the organization.
Okay, this next question is, what are some specific use cases for PKI in supply chains, and what sort of consequences can we expect if IoT is not secured?
Yeah, so it's a good question. So I'd maybe break down two of them that we see most commonly. The first one would be just supply chain integrity. And if there are those on the phone that can understand the way that like the payment card space works, it kind of follows the same, some of the same concepts, right? So, you have different components being handed off in different parts of the supply chain, and so making sure that that process is secure, so that you don't get malicious things introduced within the supply chain, that you are only using authentic products, that you can recognize those products and provide services as they come to market. It's really that supply chain process that, underneath that you're wanting to protect. The second part of it, which is one that I'll give two more, and both of these came through customer engagement. So we didn't just sit down and say, hey, this is a good idea. They came as customer requirements. But one of them is IP protection. So making sure that that the elements of the device itself that can be protected, that you can't access certain things on the device, and doing that really from the early stages of manufacturing. So it's sort of an IP protection issue. The second one is controlling the supply chain. So a lot of large manufacturers have either their own manufacturing that's globally distributed, or they're using third parties for manufacturing, and they're looking at using the same technology that in the same process effectively that is meant to make sure we can kick out authentic, good, secure devices that can be bootstrapped. They're using the same process effectively to manage their manufacturing base. So by turning this off, they can turn the manufacturer off. They can move it if they want, but as a way to sort of control licensing within the manufacturing ecosystem. That's another application of the same process, but for a different objective.
Great. We have time for one last question, Josh. You mentioned that security standards around IoT are still maturing. Any recommendations on groups or standards that you think are doing a good job in establishing good best practices for IoT security standards?
Yeah, so I'll put a caveat on it first, that there's a lot of different groups in the industry that are probably doing really good work. So my answers here are going to be the ones that I'm most familiar with. Obviously, the work being done, Secure Technology Alliance, the white papers, and those type of things, that's a good starting point. Digging deeper, we do a lot of work with the Industrial Internet Consortium. They have a library. It's kind of a treasure trove of documents that can help everything from their reference architecture, which is really geared up to what an IT architect would do, and kind of walks them all the way through the process of business objectives to requirements, and written from an IoT perspective. They have a security framework that then maps back to that. That once again, it kind of walks you through the considerations at each step, what kind of controls you should be looking at that, how does that align to the objectives and the environments. And then they just released a security maturity model, and that goes a little bit more into what I mentioned earlier with organizations trying to figure out how to put the organization together between IT and security and products and lines of business. It talks about that from a organizational maturity perspective. NIST has also done a fair amount of work in this area. It kind of started with, and still one of the biggest value creation points, I think, was there's a lot of mapping between existing regulation and existing standards and IoT environments, and now they're getting more specific around the actual use cases in industries. And then Cloud Security Alliance is another one. When you think about it more from the cloud side of things, how does that come together to support the IoT environment? So those are four that I think are pretty good. There's a lot, the OPC group, there's a lot of others that are out there that are doing good work, but that's sort of where I direct customers or other people in the industry when I get that question.
Okay, Josh, well, thank you all. We are out of time for today's webinar. I want to thank Josh Jobs from Entrust Datacard for his great presentation today. If anyone would like to reach out to Josh, you can reach him at his email address, or if you'd like to reach out to me at the Secure Technology Alliance with any feedback about this webinar, please do so. Today's webinar has been recorded, as I mentioned earlier, and will be available for playback along with the presentation deck after the webinar has been concluded. You'll receive an email with a link where you can listen to the recording and download the presentation. And in that link, you'll also have access to the online assessment quiz if you'd like to take that. Please feel free to share this information within your organization and with others who could not participate on today's webinar. We'd like to have as many people as possible have the opportunity to review and participate in today's content. So this concludes today's webinar. Thank you all and have a great day.